Hi there, and welcome to Western Axolotl's Axolotl Evolution Introduction. First of all, if you can see from behind me, I breed axolotls, and we have some wonderful axes here. But we want to talk a little about their evolutionary history, give you an idea of what axolotls are and where they come from. So with no further ado, let's talk about them. So axolotls are, of course, really common in the pet trade. These are some examples here. We'll talk about them in a minute. But I want to talk about where they sit on the evolutionary tree of life. So to begin with, axolotls are amphibians. They're in the class Amphibia, the same class that you'll find frogs in, as well as caecilians that nobody's heard of. But the difference between axolotls and most frogs is that axolotls have tails, and so they belong to the order Chordata. And so Chordata is all salamanders and newts and similar critters like that. They are within their scientific name is Ambystoma mexicanum. So they are in the genus Ambystoma in the family Ambystomatidae, the mole salamanders, if you will. There are lots of other organisms in the genus Ambystoma. Some classic ones across the U.S. we have tiger salamanders or Ambystoma tigrinum. Unique to California are Ambystoma californiense, which is a very close relative of tigrinum. And then across Mexico, there are a variety of other salamanders in this same genus, including Ambystoma dumerii, which is unique to one lake in Mexico. So there are lots of other organisms in Ambystoma, but Ambystoma mexicanum is the genus and species of the axolotl. They are similar to all other salamanders in that they are predators. Frogs are actually, when they're tadpoles, they eat vegetables or algae. But as far as axolotls go, and all salamanders, they still eat other animals, generally when they're youngsters. They have tails, again, order Chordata. They have the slimy skin, which sort of distinguishes them from lizards in appearance. And they have an aquatic juvenile stage. They start out much like a tadpole does in the water. But the difference about axolotls, and this is true for dumerii and some other groups, and we'll get to that later, is that they unlike most salamanders, they don't metamorphose into terrestrial adults. They stay in the water as adults. And this makes them super unique, well, somewhat unique, and we'll get to that later, but makes them very different from most salamanders. So let's talk a little about why this is the case and why these axolotls might do this. And we'll get to that in just a second. But just to talk about the axolotls in the pet trade, we've selected for throughout modern times axolotls that have a variety of different characteristics. This one here in the center, center left, is a wild type axolotl, and that'll grow up to look an awful lot like what I'll draw on it too here. That'll grow up to look an awful lot like axolotls do when they live in the wild. Similarly, we have some other axolotls here. This is a melanistic axolotl, although it does seem to have some green in it, but it's got more melanistic characteristics. This is a golden albino axolotl. Over here we have an albino, and here we have a leucistic. Again, most of these axolotls wouldn't exist like this in the wild, but they would exist like the wild type one we showed you at the beginning. So axolotls, again, like whales, evolved from animals that live on land. In other words, their ancestral state is to be on land as adults. This is a typical amphibian life cycle. They start as a terrestrial adult. They lay eggs. The eggs turn into larvae. These larvae hatch out after a few weeks in most cases. The larva develops some gills and forelimbs, and then eventually, once those larvae are fully developed, they go through a metamorphosis, much like frogs do. They lose their flattened out tail, their gills reduce, and they either develop lungs or breathe through their skin, and they transition into as adults that are on land. But axolotls don't do this. Okay, this is what they used to do. This is what their ancestors did. But axolotls stopped doing this, and the reason for it is what we're going to really get to at this point. Here, of course, are a lot of examples of terrestrial normal salamanders. This is an Ensatina up here in the top left. This guy right here, native to the western U.S. This is a Neoteny flavipunctatus, a really neat western salamander as well. Here's a young, recently metamorphosed Ensatina, so you can see it's already terrestrial. But here you can see the last little remnants of its gills, which I think is kind of neat too. This is one of my personal favorites. This is a Hydromanates platycephalus, a Mount Lyell salamander. These guys are found up in the High Sierra, but again, terrestrial as adults. This one here is an Ambystoma californiense, or a California tiger salamander, native to the Central Valley of California. And over here we see a one-eyed Tarica. This is a newt, again, also native to California. So these are all normal salamanders that are terrestrial as adults. But like we mentioned, axolotls don't do this. So what? Well, let's think about it for a second. What are some advantages of living on land as an adult? Imagine you're a salamander living in the water, and there's a lot of selective pressure to go out on land. Some of the reasons that salamanders evolved to go out on land in the first place, 350 million years ago to 300 million years ago, is because of all of these selective pressures. You can imagine if you're a salamander living in water, you have to deal with these guys, these fish, and maybe not exactly these fish here, but ancestral fish that were very good at being fish and very good at predators. They're either eating you or eating food that you want to eat, or living in places that you want to live, or nesting in places that you want to nest, and you have to compete with those guys, and so there's a lot of competition. Second, man, if you could figure out a way to get on land, there's plenty of food out on land. Worms and bugs and critters on land that aren't available, that you can't get access to if you're living in the water. And so that's another advantage to being on land as an adult. Thirdly, there's some places you simply can't get to if you spend your entire lives in water. It's pretty hard to swim up a waterfall, though many fish are capable of it. There are some barriers that you just can't get around if you spend your whole life in the water. But if you walk up on the land, if you're capable of doing that, you have access to upstream habitats, which is a really neat possibility if you're a salamander or a frog. And finally, there are some habitats that dry up partway through the year. Imagine this is a very typical habitat for an Ambystoma californiense, or a California tiger salamander. They live in these vernal pools. And so they breed in these pools, but it sure is nice to get out of the pool before the pool dries up. If you're a fish and the pool dries up, well, then you don't make it. But if you're a salamander, when the pool dries up, you can get out. And you can get out and go bury yourselves in the soil and wait for the rainy season and do it all over again. So there are a lot of advantages to living on land as an adult. And if you go back to early salamanders, that world was pretty harsh. Back during the Devonian, when the age of fishes, if you will, there were these gigantic predatory fishes that are nothing you would want to deal with if you're an ancestral salamander. And so there's a lot of selective pressure to either get tough or get out of the way. And this is when we first saw the evolution of salamanders. And so about 300 million years ago, some salamanders came out on the land. And they were probably pretty bad at doing what they do, but there wasn't a lot of competition. You leave the water, you go out on land, and then slowly we saw them transition or evolve into more land-based organisms. But again, the idea is pretty simple. Get out of the water, get away from the fish, take advantage of new breeding opportunities, take advantage of new food sources. Great idea to get out of there. But the reality is land has changed over the last 300 million years. Land no longer has this perfect haven from competition. Now there are other critters there. Lizards have evolved. They're fancy looking birds and the ancestors of birds. They're snakes. Now they're mammals. All of these problems on land start to arise, and it becomes less advantageous to be on land, especially if you're still a salamander, which is an awful lot like a fish with legs. You're not as well adapted to a land environment as some of these other critters. So there's a lot of selective pressure to be in water if you can get in water. And that's what we do with axolotls. So imagine this scenario here, and forgive my illustrations. But back in the good old days, you've got salamanders hanging out down in the lakes and ponds down here. But there are plenty of fish in those same lakes and ponds. Sure, there might be predators on land too, but there's so much selective pressure because of all the predation and competition in water that we start to see some salamanders develop a terrestrial adult stage. And as they're terrestrial adults, they can now migrate out of these ponds. Well, you imagine you're a salamander that gets upstream and you find this pond up here that's void of fish. It's above a waterfall or whatever it is. And remember, you're still not very good at being on land. You're kind of a half fish, half salamander, half lizard, if you will. And there's still all these land-based predators out there. And these land-based predators are a problem for you as a fish with legs, but in the water, you're actually pretty darn good at this. And so what happened in axolotls' relatively recent evolutionary past is they stopped metamorphosing into terrestrial adults. Once they found these, Shangri-La, beautiful places, these lakes where there are no fish and there are no predators, they evolved to stay in the water. And so they were much more successful in an aquatic environment than they were in a terrestrial environment, and so they retain larval morphology as adults. They stay as larvae when they develop into adult stages. And they had a lot of success doing this. So again, it's kind of a shifting evolutionary pressure. At one point, the evolutionary pressure is to leave the water, but then when you get to these lake systems and you don't have all the competition of fish, and you have lots of access to food sources, the selective pressure switches, and so there's pressure to go back into the water. And this process that axolotls do, where they stay like larvae as adults, is called neoteny or paedomorphism. And what they do is they retain their juvenile characteristics as adults, so they don't actually transition into more traditional salamanders on land. And this isn't something that's just happened with axolotls. It's happened with other species as well. And here are some classic examples. We'll go through these here. So one example, back in our actual evolutionary past, these are things called tunicates or sea squirts. And though they look nothing like us, they're actually in the same large group or the same phylum that we belong to, Chordata. And it's because as a juvenile, they actually have a dorsal hollow nerve cord, just like we do. We have a spinal cord, and so do these tunicates. And here's what looks like this is a tunicate larva, and it looks an awful lot like a really simple fish. And you can see its dorsal hollow nerve cord there. And these guys have their nerve cords, and it turns out that modern fishes, and us and everybody else, likely evolved from the juvenile stage of tunicates. And so tunicates, at some point in their past, these sea squirts or tunicates, they evolved such that their juvenile stages continued on, and even their adult stages, which were nothing like, they abandoned their adult stage and stayed in their juvenile characteristics. So modern vertebrates evolved from the juvenile characteristics of tunicates. Another example, and also a classic, is when we talk about us as humans, we look a whole heck of a lot more like juvenile chimps than we look like adult chimps. And so when you look at modern humans, we look a lot more like baby monkeys than we look like adult monkeys. So perhaps sometime in our more recent evolutionary past, we retain some juvenile characteristics of chimps as well, more facial structures, less hair, less protruding jaw, and so on. So our ancestral state is a lot more like juvenile chimps than it is like modern chimps. All right. So the big question that I think we could answer, and we'll talk about on our next little podcast or our next little discussion here, is what axolotls might look like in the future. You could imagine, if you will, an axolotl staying in the water for a very long time. For centuries and centuries and millennia, if the axolotl's environment didn't change and that aquatic environment stayed ideal, what would happen to them? How would they continue to evolve to be adapted to an aquatic environment? On land, they're kind of a fish with legs. In water, they're kind of like a lizard with gills. And so they're really not specially adapted to this environment either. But you can imagine an environment where, unchanging, an axolotl continued to have an advantage to be in water. And my question to you is, what do you think this would look like? It's something we can't predict the future, but it turns out we can actually give a pretty good answer. And so we'll actually talk about that on our next discussion. Thank you.